This is William Michael of the Classical Liberal Arts Academy, and I'd like to welcome you back for our second hour of freshman mathematics. In this course, we're going to complete or even exceed the required 120 hours of instructional time. In our first hour, we simply introduced the course and got started going through quite a bit of new information, discussing some definitions that are provided in our textbook to help us make sure that the ideas and the words that we're going to be reading in these lessons are clear and are very well understood before we begin discussing these issues in the study of algebra. After that first hour, you were assigned a set of questions to complete and submit for review, and you should have already done that, and hopefully you may already have feedback and a grade for that assignment. What we're going to do in each hour from now on is begin each hour with a brief quiz. This is not a formal graded quiz. Any real quizzes or exams or assignments will be on the Study Center page for freshman mathematics. But I'll open each hour with a brief quiz, just 4 or 5 questions about our previous lesson. And the purpose of this quiz is to simply help you think back and remember what we discussed in our first lesson as a warm-up to get you ready for the new lesson. So I'd like you to have a notebook and a pen ready at the beginning of each hour whenever you sit down for your studies. I'll give you a quiz at the beginning of each hour, and then we'll go over the answers for that quiz. And again, this is just a warm-up for each hour of instruction. Then what we'll do is spend some time reviewing the previous hour, the content of the previous hour very carefully, making sure that everything is clear. We'll use the time for review to help you study and remember the past lessons, and also to make sure that everything from the previous lessons is clear so that we can build on it when we add new information from the new lesson. We'll then go through the new material in the new lesson, and then we'll wrap up with another review, and I'll make sure to discuss any assignments that you need to complete before the next hour of instruction. So what I'd like you to do right now as we get started is you may need to pause this video, get a notebook or a few sheets of paper and a pen, and when you're ready, you can click play and start this video up again, and we'll take a quick quiz to warm up and get ready for our new lesson. So go and find some paper and something to write with. At the top of your paper, I'd like you to write your name and the date on the top line of the page on the left-hand side. I'd like you to write your name, and under your name, write today's date. On the right side of that top line, I'd like you to write freshman mathematics, and under that, on the right side again, just give a title to this quiz. Just write Hour 2 Warm-Up Quiz. Hour 2 Warm-Up Quiz. And we'll do this at the beginning of each hour so you can get used to this over time. I'm going to ask you 5 questions, 5 simple questions about our previous hour of instruction, and I'd like you to take some time and think back to that previous lesson and answer these questions. You can pause the video after I ask each question, copy the question down, hit pause, think about it a little bit, and then write your answer. And when you're finished, continue the video, get the next question, write your answer, and so on until we're finished. And then after we're through all 5 questions, we'll go back over the questions, discuss the answers, and make sure everything is clear. So the first question that I'd like you to think about and answer, jot this question down on your paper. Number 1, what is quantity? What is quantity? Take a minute and answer that question. The second question that I'd like you to answer is, what are the 2 kinds of quantity? In our last lesson, we discussed the 2 kinds of quantity. What are the 2 kinds of quantity? Question number 3. What's the difference in measuring multitudes and magnitudes? What's the difference in measuring multitudes and magnitudes? Question number 4. What is number? What is number? And question number 5. What are the 2 kinds of number? What are the 2 kinds of number? Now, you should have paused the talk and taken your time to answer those questions. If you haven't done that yet, do that. Pause this video, take your time, and answer those questions. You can take as much time as you need. What I'd like to do when you're finished, and I'll assume that you're finished now and listening again, I'd like to go over these questions and just walk through the answers and make sure these things are clear. The first question I asked was, what is quantity? And we learned that right at the top of that first lesson. We learned that quantity is anything that is capable of increase or decrease. Quantity is anything that is capable of increase or decrease. And the reason why defining quantity is important is because we learned that in algebra, quantities are represented by letters of the alphabet. Algebra treats of quantities. Algebra is a study of quantity, and therefore we have to make sure we understand what quantity is. Quantity is anything that is capable of increase or decrease. Question number 2. I asked, what are the 2 kinds of quantity? What are the 2 kinds of quantity? And the answer to that question is, the 2 kinds of quantity are magnitude and multitude. Magnitude and multitude. The third question I asked was, what's the difference in measuring multitudes and magnitudes? What's the difference in measuring multitudes and magnitudes? The difference in measuring these 2 kinds of quantity is that a magnitude is one thing. A magnitude is one thing. The definition that we learned in our lesson was that a quantity is called a magnitude when considered an undivided form, a single thing. When we measure a magnitude, we measure its parts, we measure its size. We have to take what the lesson taught us was an artificial unit. We have to make up a unit and then count how many times the magnitude contains that unit. So when we measure a magnitude, we have to create an artificial unit of measure and then use that to measure the magnitude. When we measure a multitude, the multitude already has its own natural unit. If we see a number of sheep in a field and we want to measure the multitude to know the number of units in the multitude, the unit is one sheep. And so we'll simply count how many times the unit is contained in the multitude. But the multitude will have its own natural unit of measure. So the difference in measuring magnitudes and multitudes is that multitudes have their own natural unit of measure, but magnitudes do not, and we need to create an artificial unit of measure and then count how many times that unit is contained in the magnitude. In magnitudes, we measure size. In multitudes, we measure number. The fourth question I asked, following up on that, is what is number? What is number? And we learned that number is an expression denoting a unit or collection of units. So we really can't define what number is until we know what a unit is. When we know what a unit is, because a unit is what we call one, we can then count how many units are contained in a quantity. And that number tells us how many times the unit is taken. A number is an expression denoting a unit or collection of units. And then lastly, number 5, I asked, what are the two kinds of number? What are the two kinds of number? And our lesson taught that the two kinds of number are abstract number and concrete number. Abstract number and concrete number. Those are the two kinds of number. An abstract number denotes how many times a unit is taken, and a concrete number denotes the units that are taken. Okay, so that's all for our warm-up quiz. That should help you to think back and remember what we discussed in that first lesson, just to get you warmed up and ready to dig in a little bit. Now, what I'd like to do is go through the review questions that were assigned to you for your assignment, your assessment for that first hour of instruction. Let's go through these review questions. You should be comfortable with these because you've already answered them. And we'll use this to review that first lesson and then get started with the new material for our second hour. The first question that you were asked in your assignment was, how are quantities represented in algebra? How are quantities represented in algebra? And we learned in the very first article that in algebra, quantities are represented by letters of the alphabet. So how are quantities represented in algebra? Quantities are represented with letters in algebra. That was the first comprehension question. The second question, what is quantity? And we've already discussed that in our warm-up quiz. Quantity is anything that is capable of increase or decrease. Question number 3, when is a quantity called a magnitude? When is a quantity called a magnitude? A quantity is called a magnitude when considered in an undivided form. And what you need to learn is just learn a simple summary of these definitions as we go. So you could memorize quantity is called magnitude when considered in an undivided form. But what's easier, if you know and understand the definition that's given, you can just remember magnitude undivided form. Magnitude, undivided form. You can keep it that simple to keep these definitions in your head, just memorizing the essential words of the definition. Question number 4, when is quantity called multitude? When is quantity called multitude? Quantity is called multitude when made up of individual and distinct parts. So you could just remember multitude, individual parts. Multitude, individual parts. Magnitude, undivided form. Multitude, individual parts. Magnitude, undivided form. Multitude, individual parts. Question number 5. What is the unit of measure? What is the unit of measure? We learned that one of the single parts of which a quantity of multitude is composed is called the unit of measure. So the unit of measure is one single part of which a quantity of multitude is composed. A unit of measure, the part of which a multitude is composed. Question number 6 was, how do we find the value of a quantity? How do we find the value of a quantity when there is no natural unit? And of course, this is talking about measuring magnitudes. How do we find the value of a quantity when there is no natural unit? And the answer is we simply make one up. We choose an artificial unit and use that unit to measure the quantity. Question number 7. Define numerical value. Define numerical value. We learned that the numerical value of a quantity is the number that shows how many times it contains a unit of measure. So for numerical value, you can just remember, numerical value means the number. Numerical value is the number. The numerical value of a quantity is the number that shows how many times it contains a unit of measure. Question number 8, what is a unit? What is a unit? A unit is a single thing of an order or kind. A unit is a single thing. And you can just keep it that simple. A unit is a single thing. Question 9, what is a number? What is a number? And we talked about that in our warm-up quiz. A number is an expression denoting a unit or collection of units. A number is an expression denoting a unit or collection of units. Question 10, what does an abstract number denote? What does an abstract number denote? So abstract number is the first kind of number. What does an abstract number denote? An abstract number denotes how many times a unit is taken. An abstract number denotes how many times a unit is taken. And remember, I explained that abstract means taken away from material or taken away from the concrete number, taken away from units, just number. Abstract number. Then we were asked in number 10, the second part of the question was, what does a concrete number denote? What does a concrete number? And a concrete number denotes the units that are taken. Then we have question 11. What do the letters used in algebra represent? And this is our last question. What do the letters used in algebra represent? And we learn that in algebraic computations, letters are considered representatives of numbers. In algebraic computations, letters that we see are considered representatives of numbers. So that's all for that first lesson and the comprehension questions that you were assigned. I hope that's a helpful review of that material. I want to help you to learn it and become comfortable with it. Even just by listening to these talks, I want you to become familiar with the content of these lessons. If you're thinking to yourself, oh, this is so boring, we're going over this material so many times, I already know all this stuff. Well, that's a good thing. That's what you're supposed to do. And I hope that these lessons help you. Realize they're not boring. It's just a matter of working to make sure that all of the material is covered and that you understand it all clearly and are very comfortable with it. If you are comfortable, that's great, because it's time for us to continue and move on with new lesson content. So, in our lesson, we're going to begin in the textbook with rule number 12. Rule number 12. In the first lesson, we really talked about quantity and number, sort of the basic stuff of mathematics. In this second lesson, as for the new material, we're going to get into a little more about the kinds of questions that we study. What do we actually study and do in algebra? So point number 12 in our lesson says there are two kinds of questions in algebra. There are two kinds of questions in algebra. The first kind of question is a theorem. And the second kind of question is a problem. So we need to be careful, because normally modern students will just refer to anything that they do in math as a problem. But there's a difference between two kinds of questions that we ask and try to solve in algebra. Two kinds of questions. The first kind of question is a theorem, and the second kind of question is a problem. And it's important to understand these because the same is true in other subjects. It's true, for example, in geometry. There are two kinds of questions. So what is a theorem? The first kind of question that we study in algebra. What is a theorem? Rule number 13 tells us, in a theorem, it is required to demonstrate some relation or property of numbers or abstract quantities. In a theorem, it is required to demonstrate some relation or property of numbers or abstract quantities. An easy way to think about a theorem is a theorem requires us to prove something. A theorem requires us to prove something. We'll be asked to prove something is true. That's what we do in a theorem. The second kind of question that we seek to answer in algebra is a problem. The second kind of question is a problem. Rule 14 tells us, in a problem, it is required to find the value of some unknown quantity by means of certain given relations existing between that quantity and others which are known. Let me read that again. Listen carefully. A problem, or in a problem, it is required to find the value of some unknown quantity. In a problem, it is required to find the value of some unknown quantity. by means of certain given relationships existing between that unknown quantity and other quantities which are known. So, knowing certain quantities and understanding the relationships between different quantities, we work to find the value of some unknown quantity. We use what we know to find what we don't know. So in a problem, we seek to find some value. In a theorem, we seek to prove something. In a problem, we seek to find some value. In a theorem, we seek to prove something. In a problem, we seek to find some unknown value. In a theorem, we seek to prove something. In a problem, we seek to find some unknown value. Those are the two kinds of questions that we ask and study in algebra. In Rule 15, we finally get around to describing algebra in more detail. And I really want you to pay attention to this because most modern students, and you can test this on your friends or relatives, even your parents. If we ask a modern student, what is algebra? We'll find that they can't answer. We'll find that very few students can answer the question, what is algebra? And just think how ridiculous that is. Think how ridiculous it is for kids to sit in a class for 180 days in a school and talk all the time about how they're studying algebra. What are you studying? Oh, this year I'm studying algebra. Oh, really? I'm studying algebra too. Are you studying algebra? Algebra, algebra, algebra. We hear about algebra all the time. But if you were to stop one of these kids or stop one of your relatives and ask them, what is algebra? And I encourage you to do this. Ask someone, what is algebra? You'll find that no one can explain it. For all the talk about studying algebra in modern schools, you'll rarely find any student who can tell you what algebra actually is. So let's avoid that mistake, not make ourselves look silly, and let's take the time to learn what algebra is so we can answer such a simple question. What is algebra? In rule number 15, we learn algebra is a general method of solving problems and demonstrating theorems. Algebra is a general method of solving problems and demonstrating theorems. Listen one more time. Algebra is a general method of solving problems and demonstrating theorems. So algebra is a method of answering the two kinds of questions that we ask in the study of algebra. Algebra is a method. Make sure you note that. Algebra is a method. In the study of algebra, we're learning how to do something. We're learning a method in algebra. We're learning a method about how to answer certain kinds of questions. In algebra, we're learning a method of solving problems and demonstrating theorems, the two kinds of questions. We're learning a method of solving problems and demonstrating theorems. Keep repeating that to yourself. In algebra, we are learning a general method of solving problems and demonstrating theorems. In algebra, we are learning a general method of solving problems and demonstrating theorems. So at the end of your study of algebra, you should possess the knowledge of a method of answering certain kinds of questions, questions about quantity. You should have the knowledge of a method of answering questions about quantity. That's the purpose of the study of algebra. Now, the rule, number 15, goes on and says, algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. So what we do in algebra, or what we learn in algebra, is a method of solving problems and demonstrating theorems. But like I said, we do that in geometry. What's different about algebra? What's different about this method that separates it from geometry? Algebra is a method of solving problems and demonstrating theorems by means of figures, letters, and signs. That's what makes algebra different. Not what we do. Algebra simply teaches us how to solve problems and demonstrate theorems. That's not what's unique about algebra. That's true also of geometry. What's different about algebra is how we solve problems and demonstrate theorems. How? That's what's different. The answer to that question, how, is by means of figures, letters, and signs. By means of figures, letters, and signs. And Rule 15 ends with this statement: letters and signs are called symbols. Letters and signs are called symbols. So algebra is a method of solving problems and demonstrating or proving theorems. And the way that we do this in algebra is by using symbols. Algebra is a method of solving problems and demonstrating theorems by means of symbols. And that's what's very important to understand. In algebra, we learn to solve problems and demonstrate theorems using symbols. Using symbols. I'm going to say this one more time because it's very important. In algebra, we learn a method of solving problems and demonstrating theorems by means of symbols. Okay? Now, why is that important? Why is that important? We can compare algebra to arithmetic. We can compare algebra to arithmetic. In arithmetic, we learn to solve problems. You are asked, how many is 4 plus 5? How many is 2 times 7? How many is 15 divided by 3? We learn to solve problems in arithmetic. So that's not new. We've already learned how to solve problems. But in arithmetic, we don't use letters and signs. We only use numbers in arithmetic. In arithmetic, we learn to solve problems using numbers. In algebra, we learn to solve problems and demonstrate theorems using symbols. That's what's different. And why is that important? This is important because in arithmetic, we answer specific problems. We're told how many things there are and how many times they're taken. We're told how many things there are and how many times that needs to be divided. We're told how many things there are and how many need to be taken away, or how many need to be added. We're told the numbers in arithmetic, and we're asked to find solutions when we know all of the numbers. In algebra, we learn a method that's useful in ways that arithmetic is not useful. Remember, we talked about how in a problem, it's required to find the value of some unknown quantity. In real life, in different sciences and studies and different businesses and kinds of work, we have to find values for unknown quantities, quantities that can change. We want to understand, for example, if I'm a carpenter and I build a deck for someone on their house, I need to know if my prices that I charge to build a deck are going to leave me with a profit in the end. Am I going to make money or am I going to lose money? How can I figure that out? How can I decide how much to charge a person for work that I'm going to do? How can I know whether it's going to make a profit or not? Every house is different. Every project is different. Every customer wants something different. There are different kinds of wood. There are different kinds of screws and nails. There are different styles of decks. There are different kinds of wood, all different kinds of variables, different sizes of decks, on and on and on. How can I know what my price should be? How can I know if I'm going to make any money? I can't afford to lose money, so I have to know a rule that allows me to be sure that I always make a profit. Well, because all of these different quantities can change, as I said, we want to know a rule. We want to develop a rule so that when these different quantities change, we can still figure out whether or not we're going to make money. Algebra is the method that allows us to solve problems when quantities can change. So, for example, if I'm trying to figure out how much I should charge to build a deck on someone's house, the first problem that I'm going to have is I'm going to have to know how much the wood is going to cost, because the price of wood changes all the time. So how can I figure out what my prices should be if the price of wood is always changing? Well, I can just use a symbol to represent the price of wood. I can say the letter W is going to represent the price of wood. Then I can think of another quantity that's always going to change, and that is the size of the deck, the amount of wood that I'm going to need. And so I could use another letter to represent the size of the deck. I could use another symbol to represent the kind of wood that the homeowner would like the deck to be made out of. And so I can use symbols to represent these quantities that may change. And I can make up a rule that I can always use to determine the price that I'm going to charge for a project. I can use algebra to make a rule. And that's a simple example from business. To give you another example, I own a farm, and on our farm, we had a dairy where we had a number of cows that were producing milk, and we were selling the milk to neighbors who came and purchased the fresh milk from our farm. Well, we had to decide how much to charge for a gallon of milk. And it sounds pretty simple, but it's really not, because there are many different changes. First of all, the cows don't produce milk all year round. Some cows will be producing milk. Some other cows might be pregnant and might not be producing milk. And so cows change throughout the year. Some cows are milking, some cows are not milking. Some cows make a lot of milk, some cows don't make a lot of milk. Some cows eat a lot, some cows don't eat as much. Sometimes the price of the feed for the cows changes. So there are all of these different issues that have to be thought through in order for a farmer to decide what the price will be for a gallon of milk. It's pretty complicated. And these prices and things can change at any time, and the farmer has to always know that his price is good and that he's still making a profit. And so if the price of food goes up, the farmer has to be able to quickly calculate how the price of his milk needs to change. If a cow gives birth to a new calf, and now that cow is making milk, and the farmer is going to have more milk every day, he needs to be able to calculate how much he should charge for his milk now that there's more available. And this goes on and on. Many different things change, but you can see how for a farmer to run his business, just like a carpenter, he has to be able to make calculations when quantities are changing. And in real life, because things are often changing, we can't just have arithmetic as the only method that we use to solve problems, because some problems can't be solved by arithmetic. There's simply no knowledge of the numbers because the numbers can change, and we need to understand a rule that allows different things to change. Arithmetic can't help us when the values change. Algebra teaches us how to think about numbers and quantities when quantities are changing. Algebra is a general method of solving problems and demonstrating theorems using figures, letters, and signs. The letters and signs are called symbols, and they're used to represent quantities that aren't always the same, quantities that can change. And so algebra becomes very useful for us when we're trying to work with quantities that are changing so that we can understand relationships. If the price of feed goes up, the price of the milk has to go up. If the amount of milk being produced goes up, the amount that we charge for our milk can go down. We can make rules that help us to run businesses and solve other problems. Think about this. I'll give you one more example. When you drive in a car, your parents, let's say your parents are driving. I assume that you're not old enough to drive yet, but when your parents are driving, the speedometer on the dashboard tells them how fast they're going. And you can look at the speedometer and there might be just a digital number on the dashboard, or there may be a dial where there's a hand like on a clock that's moving, and there's numbers for the speeds on the dashboard. And you can see the hand moving as the car speeds up. When you're driving on a highway, it's pointing to maybe 60, 65 miles per hour. That speedometer on the dashboard is an example of how algebra works. The distance that you're traveling and the time that you're traveling are constantly changing. And the speedometer follows a formula or a rule based on algebra and is constantly solving a problem where the distance and the time are changing. As the distance and the time are changing, the speedometer is constantly telling you how fast you're going. The speedometer is constantly carrying out a formula using algebra to tell you your speed. The speed is equal to the distance that you travel divided by the time. The speed tells you the distance you will travel divided by the amount of time. That's why we say miles per hour. How fast are we going? We're going 60 miles per hour. Miles, distance, divided by hour. So the speedometer in the car is constantly solving a problem using algebra, telling you how much distance you can travel in a certain amount of time. That's an example of algebra at work, giving you some helpful information. So, once you learn what algebra actually is and how it can help you, you're going to realize that algebra is all over the place. All around you, algebra is at work. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. So I want you to make sure that you know what algebra is, and I want you to understand why using letters and signs is important. That's the key to understanding algebra. Algebra uses letters and signs because we don't know all the numbers. The numbers can constantly change, and the letters and signs represent those changing numbers. So if I don't know how far I'm going to travel, I could just put the letter D, and the letter D can represent distance. And if I don't know how long I'm going to drive for, I don't know the time, I can just use the letter T to represent the time. And I can say, if you tell me the distance, D, and divide that by the time, T, that will tell us our speed. I can use letters and signs to solve problems. That's what we do in algebra. So some students sit around and ask, why do we have to study algebra? Why do we need to learn all these rules and lessons in algebra? When am I ever going to use algebra? The answer is, you use algebra all the time. All the time. It's just that many of the things that we use have algebra programmed into them, so you don't actually have to do the problem solving because the machine does it for you. But we need to understand how that machine works and what it does and why the answers that it gives us are true. And in order to understand these things, we need to study algebra. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. The letters and signs are called symbols. So that's all for the new material in hour number 2. You should know that there are 2 kinds of questions in algebra, theorems and problems. You should know that a theorem is a problem, or I shouldn't say a problem. A theorem is a kind of question where we're required to demonstrate some relation or property of numbers. In a theorem, it is required to demonstrate some relation or property of numbers. And in a problem, the second kind of question, it is required to find the value of some unknown quantity by means of certain relations existing between that unknown quantity and other quantities which are known. And I gave you some examples of this that are around us in everyday life. And then lastly, the definition of algebra. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. So your assignment to follow up this second hour is to study this lesson for mastery. Hopefully, in these instructional hours, I go over the materials so much and provide so much review that by the time you've listened to them, you're very comfortable with all the material. That's my goal. But still, I'd like you to go back, read the text lessons, study them carefully for mastery, memorize the definitions. This is what's really going to set you apart from other students. Other students complete lessons and they go through algebra and they really don't know what they're doing because they never learn the definitions. They never really learn the rules or what they're doing or why it matters. Be different. Really master these lessons. They're very important. Take your time, study the lesson carefully, memorize the definitions. Make sure you understand everything that you read in this algebra book. If there's something you don't understand, contact me and ask. Ask to have it clarified or explained some more. Make sure everything is clear. Study the lesson text. Complete the lesson assessments that are going to be in the study center on the freshman mathematics course page. Usually, there will be a written assessment where I'll ask you some questions, and you'll need to answer those questions from your lesson. I'll review your answers and give you a grade. But sometimes I'm going to post quizzes, and the quizzes are going to be challenging and are really going to test your knowledge of the lessons. So, study the lesson for mastery, review these talks if you find them helpful, and complete the lesson assessments that are on the course page for freshman mathematics in the study center. That's the end of our second hour of instruction. I hope that was helpful. And It's time for you now to study, complete your assessments, and get ready for our third hour in freshman mathematics. God bless your studies.